Hello everyone, welcome back to the channel. Today we are deep diving into something that can shape your tech career for next 5 to 7 years. The ultimate data engineering roadmap till 2030. Let me start with this. Data is a new oil, but unlike oil, data keeps growing faster, deeper and more valuable every single day. From your AI to analytics, cloud computing to machine learning, everything depends on clean and well structured data. That's exactly where your data engineer comes in. Companies across the industries, like from finance, healthcare, retail, every domain are heavily investing in data infrastructure. That's why, even in this shaky job market, data engineering roles are keep exploding in demand. But here is a real reason. While there is a huge demand for data engineers, most people lack the right skills to actually do the job. And that's exactly why companies are struggling to find the skilled data engineers. Demand is high, but the talented data engineers, that gap is even more higher. So in this video, I'm going to break down the skills, tools, platforms, and the trends you need to master so that you can become a very good data engineer from 2025 to wait till end 2030. Whether you are just getting starting out or looking for your full proof career, this roadmap will give you clarity, direction, and confidence you need in your journey as a data engineer. So, without wasting any time, let's get started. So, when you come to any data engineer, there are few certain things that are fundamentals of any data engineer. That is, you have to get always started with one of the major important technology or tool, or you can say something called as SQL. SQL is bread and butter for any data related job. Either it might be data engineer, data scientist, data analyst, any data engineers, SQL is must and should. So if you're getting with data engineer, first get started with something called a SQL. Inside SQL, we need to learn few things. First and foremost, you need to understand what are this OLTP system and OLAP system. Where we use this OLTP system, where we are going to use OLAP system. Once you get that brief idea, what are databases, what are schemas, what are tables, how we create a tables, how we create a objects inside our databases, how we insert our data, how we update, delete, truncate, or drop any of the objects inside our SQL. We need to understand that first. And once you understand the object level, then deep dive into the actual working with your data. That is how you select the data, how you filter the data, how you group by, how you do ordering. All these of data massaging you do with respect to SQL syntaxes. Then you learn something called the transactional control. Now you have done certain things inside SQL. By mistake, you have deleted certain records. How to roll back that? How to commit that? All this information you can learn under something called as a transaction control. Once you learn this high level integration, high level things, then deep dive into constraints. Okay, I need to have a clean data in my table. Then I need to make these constraints inside my table so that whatever the data I'm adding inside my table should be always intact and well structured data. For that, on top of your table, we'll be adding certain number of constraints saying that don't have any null records in my table, or else we are joining multiple tables. We use something called as a primary key and a foreign key to join or combine the tables, having that relational integrity between the different tables. For that, we need to know about these things. Then we need to understand what is unique constraint, check constraints. These are the must and should known constraints. Once you know about these our constraints, learn little bit about the data types inside your relational database, because data types are where you are, the way you store your data inside your SQL depends on this something called as a data type. Once you learn about data types, then you move on to the next complex part. Now you have multiple tables. Now you need to join that particular table and get a exact results which we need. So that's why we work with something called as joins. Now joins are, there are different types of joins inside the SQL, the inner join, left outer join, right outer join, cross join, self join. Now we need to understand how this actually joins works inside our SQL. Very, very important topic for any of the data related jobs. We need to master joins. One must and should question will be coming in your data engineering interviews, that will be 100% on joins, because joins is that much important inside your data career. Once you master your data joins, then you move on to something called as a subqueries and CTEs. How you can work with multiple tables inside temporary result set, that will be working with something called as a subqueries and CTEs. And once you master this, then go on to the intermediate level, that is something called the Windows functions, analytical functions. You have to learn how to add, how to subtract, all these different concatenation, working with different date functions. You have to learn these different inbuilt functions that are there inside your SQL. Once you learn this, and if you want to take your career next level, we have to learn something called as a PLSQL, programming language SQL, where we'll be building our store procedures, functions, indexes, views, and also a bit of the performance optimization. This is a very high level I'm explaining, where you need to at least know these knowledge when you get started with SQL. You can give at least 2 to 3 weeks to master this particular SQL. Now, once you finish your SQL, something that is related to SQL is data warehouse. Inside data warehouse, we need to understand few things. Now, what are these data warehouse? What are these data marts? How we can divide our data into different format like star schema and Snowflake schema. What are these dimensional tables? What are the fact tables? How we do this ETL process and ELT workflows? How we build our slowly changing dimensions, that is to have that historical data. We use something called as a slowly changing dimension. You need to master this. Now, these are must and should. Since it is related to SQL, get started with SQL, then master your data warehousing. You no need to learn data modeling kind of things, because to get started, this information is much more enough to get started, where you will be implementing this inside your code. So it is enough to get started. So first understand these basic concepts, like first get started with SQL, then data warehouse concepts. So once the data warehouse concepts is completed, we will move on to the next main important pillar of data engineer, that is something called as Python. Now under Python, we have to concentrate on something called as core Python, where we will first understand basic syntax, how to write a basic syntax, what is this indentation. While you're writing any of the code inside your Python, everything depends on the indentation of your code. We'll learn what are variables, what are how we do data types, data typecasting, all this information you need to know. And then we move on to the something called collections. Now, collections are nothing but how you organize your data inside Python. So there are n number of data structures and algorithms that you can learn, but the widely used inside your data engineers are list, tuple, text, and dictionary. You need to master these four data structures without any compromise. You need to learn thoroughly these things, solve as many as problems, as many as coding problems on these four, that is list, tuple, set, and dictionary, and learn to do something called the list comprehension, dictionary comprehension, where you will be learning to write a complex code into a simple one line of code. You have to write, we have to optimize that particular code. You have to learn this code using Python. Then you learn looping inside this particular data structures, how I can loop the data, how I can use for each loop, while loop, to get the exact type of result that is demanded using this data structure. We need to learn on top of that. Once you complete that, learn about operators, expression, greater than, less than, equal to. All these are the operators you have to learn inside your Python. Then go on to the flow control, that is if else logic. Again, looping condition we are covering here, but this is more with respect to in generic, where you learn for loop, while loop, break, continue, all this kind of flow control, how we can do with respect to programming language. You learn that, then move on to something function. Now here above we are writing all has a block of code, but we have to put that into one compiled one form of code, then functions come into the picture where you define once and reuse that function again and again. So we need to understand what are function, how we pass arguments, what are the different types of arguments that are there in function, and how we return the values. We need to understand this. Then once you have that high level of functions, then try to learn exceptional handling. If there are any errors are coming, how you handle that particular error inside your code so that it will not break your code. We have to learn this exceptional handling. Then there are something called as modules and packages. You need to build a different function and you have to convert that into a form of packages where you can learn, create that, and work on top of that packages. We need to learn on this. These are the core concept we have to get started. Once you learn this, then move on to something called as file handling using Python. Now we need to know how to read and write our JSON file, PSV file, text files, how you work with the OS modules like directories from your local, how you can bring the data to any of the cloud or any of the directory using Python. We need to understand that how we parse our JSON, how we parse our data type format, all these things, and also how we can connect to any of the databases or Snowflake using Python connector. We need to know that with respect to Python. And once you learn this, there are a lot of inbuilt libraries there. N number of libraries are there. But to get started, we can get started with Pandas, JSON, CSV, OS, and Boto 3 is very important for your AWS interaction. Now, once you finish your Python, you can give at least 3 weeks of time to master this particular Python. 3 weeks for SQL, 3 weeks move on to the next pillar, that is something called as big data tool Apache Spark, or you can say Pyspark. Earlier, we used to ask students to learn how to be high these kind of scoop kind of things. But nowadays, since everything is moved to cloud related tools, we need to understand one thing that is widely used that is called as a Apache Spark. It's a big data tool which is mainly used for processing your TBs of data. Okay. Now, in that way, first we need to understand what is Spark architecture, what are this driver node, execution node, cluster manager, what is this Spark context or Spark session, what are data frames, what are RDDs, then what how you write a data from CSV, Parquet, JSON, and how to read and write every this kind of operation you need to understand. Once you understand this, then understand something how to manipulate data using Pyspark. We can use SQL, how in SQL you are manipulating your data. In the same way, you can manipulate your data with respect to Pyspark. That's why if you master SQL, you are almost mastered your Pyspark. Only you need to know is how to write that particular code in Pyspark. Since this Pyspark is built on top of Python, you have learned Python also. Now it is much more easy to work with your Pyspark. Once you know these things, then learn about operations. Then you write a PySpark job scalable transformations that are wide and narrow transformations. Then master the cleaning and transformation of data using a lot of functionalities inside your PySpark. Once you master transformations, once you know how to read a data, how to write a data, how to transform a data, how to get a desirable results from your data, next things comes up is something called the performance optimization. There are a lot of performance optimization, but this is mainly with respect to your interview. They're going to ask this main performance optimization. What is repartition? What is coalesce? What is caching? What is persist? What do you mean by broadcast time? What are this partition and shuffling inside your PySpark? What is lazy evaluation? What is fault tolerance? What do you mean by data skewness? How do you prevent this particular data skewness? And there is something called as adaptive query execution. Now, what is this inside of PySpark? We need to know this. And once we master our PySpark, again, give 2 to 3 weeks for PySpark, master these concepts. Now, these are the fundamentals for your data engineer. These tools are must and should. First, you get started, learn these things. And once you learn the main four pillars that I would say SQL, data warehouse, Python, and Spark, then we'll go and implement that into our platform. There are different coding platforms. then widely used in our current market demand is one is Snowflake, where mainly your SQL related projects will be there. If any project want to completely depend on SQL for data processing, they will go something called as a Snowflake because it has wide variety of features. Okay. Now, with respect to Snowflake, what we need to understand? We need to understand what's the architecture of Snowflake. What do you mean by warehouse? How this particular Snowflake is running? It depends on something called a compute called as a warehouse. We need to understand that. Then how to create a table, schemas, views inside our Snowflake. What are the different types of tables that are present? That is one is permanent, transient, and temporary. You need to understand these different types of tables. Now, what are the stages? Now, we have a data inside our AWS S3, ADLS, or from your local. You need to bring that to your Snowflake. Then we use something called as stages. You need to understand what are these stages. Then how to load a data, how to unload a data. We can use something called as copy and snowpipe. Continuous integration of data you want to use. Then we know something called snowpipe. We need to know how to integrate this. Then we need to know how to work with a JSON, Parquet, or unstructured or semi-structured kind of data. How to process that with Snowflake. We need to understand that. Now we have learned the concepts of slowly changing dimension and other data warehouse concepts. Now we need to implement that into a certain tool. Then that is something called as a change data capture or slowly changing dimension that you need to know how to implement that inside your Snowflake and how to automate that using tasks inside your Snowflake. Then few other features are there inside Snowflake that you can do something called cloning, you can do time travel, you can create a store procedure. Now you are learning store procedure inside your SQL. Now you need to implement that you are implementing in the cloud, and inside Snowflake, you can write SQL, JavaScript, and Python store procedures. You need to understand how we can do more concentrate on SQL, but have some understanding on JavaScript and Python. Earlier, all the projects were built on JavaScript store procedure, but now everything is built on SQL. So you need to have a high level of understanding. Please don't go and start learning JavaScript. That's not advisable, but just learn how to read something, how to loop the things, how you can learn that particular code, whatever the code is there. You need to understand that particular code because all old projects are still using JavaScript store procedures. Once you learn about that, then there comes something roles based access control or data masking or data governance inside your Snowflake. You need to learn that these are the advanced concepts. Then there are certain things called as a directory table, external tables, event tables, dynamic tables, which are mainly used for building your dynamic pipelines. You need to understand that. Then come on to the optimization part. Learn what are micro partition, how do you do query profiling, what is this clustering, leak clustering, and other kind of optimization that you need to understand while coding inside your Snowflake. You need to learn this. Now, your Snowflake is completely a SQL based coding platform. You'll be writing all codes inside SQL and you'll be constructing all the objects inside your Snowflake. But you want to move on to something called as a low code platform, then that comes with something called a DBT. Now, DBT is highly in demand because we are just making use of certain configuration inside DBT and it goes on to the data warehouse which we have connected and execute the same functionality that particular data warehouse doing with the complex scenarios. Now we are making it much more simpler with less coding. Then DBT comes into the picture. You need to understand what is this DBT code, DBT cloud, how to set up this DBT cloud, how actually these particular configurations are done inside your DBT using something called as a YAML files, how we create a models, how we create a source, how we create seeds, snapshots. Snapshots are nothing but the SCD which we are implementing inside our data warehouse or Snowflake that you can implement with a simple configuration inside our DBT. You need to understand that. Now, then once you understand those things, there are something called as a Jinja template that is similar to that of your SQL on top of our SQL to make it a programmatical inside your DBT. We use something called a Jinja. Okay, we need to understand that and we can create n number of test cases for our tables, whatever we have built, and we can also document and version control. So now you are doing each and every development. Now your DBT gives that configuration to directly integrate with your Git, move from one environment to another environment, or move from feature branch to the your main branch. You implement all your CI/CD, all DevOps kind of work with click of one click. No need to have setup. So that's the reason DBT is having very high demand in current market, and Snowflake plus DBT is one of the high demand job skills in the current market. Now, once you master this DBT, we have learned Pyspark. Inside Pyspark, what I would suggest is while learning whatever the Pyspark you are doing, do that on top of your Databricks. Now, Databricks has also given you a free edition where you can make use of each and every features of Databricks. Now, if you are doing any transformation, writing code, write that inside your Databricks notebooks. Work with something called as a data frame. Understand what are these Delta Lake tables are. That's open table format, how you convert your files into a tabular format, how to build a certain jobs and pipelines inside your Databricks. Understand that, how you schedule a job, how you mount, how you bring the data from different sources into your Databricks. You need to understand that. And then we should have a high level of understanding on something called as a Unity catalog or data governance inside your Databricks. And there is a new thing that is being developed by your Databricks, that is something called as a Delta Live Tables. That is a declarative way of programming with low code. Now, what was you were doing with a low code that with respect to PySpark, you want to a Spark architecture you want to do, then this DLT come into the picture. There's a very high level of things I have explained. We can deep dive into these things. Now, once you learn about something PySpark and Databricks, now you're good to go with something called a Snowpark as well. Because whatever the code you are writing inside PySpark or Databricks, you can write the same code with respect to Snowpark inside your Snowflake. So there are any requirement which we want to work with something called as data frames, then Snowpark come into the picture, but it doesn't make use of your Spark architecture. Whatever it is working on top of your Snowflake data warehouse, and it is converting your any PySpark or Snowpark code into the SQL code in the backend, and then it is executing inside your Snowflake. So since you have learned Pyspark and Databricks, now almost 90% of Snowpark you have learned, only you have to learn how to integrate your Snowpark with Databricks. The coding, everything remains same with respect to that of your Pyspark, but now you are using Snowpark data frame APIs instead of Spark data frame APIs. Now you need to understand how to write any Python code inside your Snowflake. What are these worksheets? You need to understand how to create this particular store procedure using this Snowpark code and how you integrate this particular with respect to other tasks inside your Snowflake. You need to understand that. Now, in this way, we built our foundation. Now we are using that particular foundation onto the cloud coding platforms. That is something called a Snowflake or maybe DBT or Databricks. We are making use of that foundation. Now, once we learned these tools, now you're almost good to go, but why stop here? Okay, now we are targeting till 2030. We should be well skilled data engineers in the job market. So I would suggest go and add one of the services, that is AWS. Now, why I am suggesting AWS services, wherever you go, very good high product-based company or any of the companies that are dependent on lot of AWS infrastructure, and that's why they are still using infrastructure. Almost 40%, even of the current any data related jobs still have that AWS services. Although Azure is keeping up, increasing, but AWS is also still have that huge market. And if you want to target any good product based companies in the future, then you have to go with something called as AWS service. Now, inside this particular AWS, we need to learn how this particular cloud fundamental works, how our cloud works, how we can integrate with something called as data lake service like S3, how we can keep all our raw data into S3 buckets. There is something you have data into your S3. Now we need to query or profile or see that particular data without moving into any data warehouse. Then there comes something called a service called as a AWS Athena. We need to understand that. Now, whatever the code you write inside your AWS, there is a library called Boto3, which is mainly used for automation of all your services inside your AWS. Learn how to integrate these all services with respect to Boto3. Then, if you want to go with event-based pipelines, you want to create certain event. Now, for example, a file is coming inside my S3 bucket. As soon as that file comes, I want to trigger certain things. Then we have to make use of something called as AWS Lambda. Now, inside AWS Lambda, you can write a Python-based code, the serverless service, where you can use for transformation for small purpose, but not a huge transformations we can do, but it's a widely used service in your AWS project. Then comes actual big data processing tool, that is something called as AWS Glue. As you have learned Pyspark, you implemented that Spark and Pyspark inside your Databricks and also Pyspark. Now we need to know how to do the same with respect to AWS service. Then that is with respect to Glue. You need to know how to integrate your Pyspark code inside AWS using AWS Glue notebook or scripts and do this particular ETL process inside AWS and transform and prepare your data. Then your AWS Glue service comes with the picture. Now you are done all the transformations, you are done all these things. I need to orchestrate my data inside my AWS only. At that time, AWS step functions come into the picture, which is mainly used for orchestrating of your whole pipeline inside AWS. Then comes something called the event bridge. Now we have orchestrated. Now I need to schedule this on the certain amount period. For example, every morning 6 a.m. I need to schedule, or as soon as any file comes to my S3, I need to trigger certain pipelines. At that time, for that, based on the rule-based triggering or any of the triggering of the workflows, your event bridge comes into the picture. You need to understand how this particular event bridge works. Then there comes something called secret manager. You are keeping all your password information, everything inside the secret manager, and you are accessing that through Boto3 inside your code. We need to understand that. We need to understand what is a simple notification service and simple email service, where it is widely used for sending notification to the users whenever there is a failure or any information we want to send. That we need to know this particular services. Then try to understand what is this relational DB. I want to host your MySQL or SQL Server or any other databases on the cloud where you are doing all the online transaction OLTP system. Then without worrying about the data servers in the back end, I will host that inside my something called as AWS. Then there comes something called a relational DB. You need to understand this. Now, since we are mastered already Snowflake, we need to understand if we are not going with Snowflake, inside our AWS, if you want to learn what service I can do, then that is called something called as the AWS Redshift. You can learn this particular high level. You can compare your AWS Redshift to Snowflake, and you can see what are the differences, what are the pros and cons we have, so that everything you have done inside Snowflake that you will be doing with respect to Redshift. But there are certain limitations. All the features you cannot use since Snowflake is a wide variety of features. Wherever Redshift, you don't have that particular features, but still, if your company don't want to go with another services, everything they want to build on AWS, then they will go with something called as a Redshift. Now, these are the services must and should you have to learn. But if your time permits, learn something called as a EMR. Amazon EMR is nothing but where you host your Spark or Hadoop cluster instead of serverless. Now your Glue was serverless. Now you want to configure everything Spark by yourself, and you need to host that, and you need to make use of that cluster, maintain that cluster. Then Amazon EMR comes into the picture. Have a big idea on that. If you want to work with a NoSQL database, that is, you want to work with a semi-structured kind of a data, then Amazon DynamoDB come into the picture. Have a brief idea on top of that. And if you are doing something called the monitoring of logs, metrics, everything, you are working with n number of services and you need to monitor those services, then CloudWatch come into the picture. Have a brief idea on top of that. Then try to have one streaming integration, either Kafka or AWS Kinesis, which are mainly used for continuous streaming of data. Try to understand once you get that particular streaming continuous data, how to send that to your data warehouse, for example, Snowflake. and build a project on top of that. Now, this is a very high level which we have explained. These are must and should services which you know, should know inside AWS services. Now, once you complete your AWS services, we have learned a lot of things, but only learning things will not give you confidence. We have to build a project. We have to integrate that end-to-end pipeline. So try to integrate with your AWS integration with respect to Snowflake and Databricks, because this is a modern data engineering tech stack that are widely used inside the companies. Use your S3 bucket to load the data into your Snowflake or Databricks, build a Snowpipe, or using Glue, integrate your Glue services to add the data into your Snowflake, build a project on top of that, do all the transformation in Databricks and bring that with respect to AWS, orchestrate that, orchestrate using something lambda function, step function. You have all these functions you need to orchestrate and bring the data to Snowflake. Try to build that project, do the data migration project. You have a data on your on-prem. You need to bring to cloud. That might be any data warehouse like Snowflake or Databricks using AWS. Try to learn that. Now, I would suggest since you have mastered one cloud, now you can easily move on to the other cloud as well. Get started with one cloud. Once you are good with that, try to understand the same services what other cloud is giving. For example, Azure. Inside Azure, there is something called as a ADF. Try to understand what is this ADF service, Azure Data Factory, where it has wide variety of activities where you can orchestrate your pipeline, bring your data from on-prem to the cloud using something called as a data migration. You can do. We can do complete end-to-end orchestration. You can connect your Databricks notebook and do the transformation, or you can connect your Snowflake scripts and do the transformation and orchestrate that from end to end and build a dynamic pipeline. Try to use your area at least so that you can learn a multi-cloud data engineer. You can call yourself and integrate and build a project. Projects are must and should. Once you build a project, you will get that particular confidence to go ahead. Okay, that particular confidence only comes once you build a project. So once you integrate all these things that you are integrated, now these services are good to go. But there is one more service, that is Apache Airflow, or this particular tool is having high demand, which is widely used mainly for simple orchestration services with respect to your Snowflake or AWS. We have orchestration inside our AWS, that is, which we have seen is step function. Now, some companies will use something called as Apache Airflow to orchestrate, where we will be writing directed acyclic graphs using something called as a Python, which we have already mastered in our foundation. Now we need to implement and build a project, or we need to build up pipelines inside our Airflow and understand how we can integrate that with respect to Snowflake or any other AWS services. Now, once you learn Airflow, then comes something called as a open table format. Now, this is a very important. Now, since data is keep on growing, your data warehouse will not be able to handle each and everything. You need a something called as a lakehouse architecture, where on top of your data lake, acid properties come into the picture, where you can do time travel, schema evaluation, where you can directly work on top of your data lake. Then these open table formats come into the picture. One is data lake, which is widely used inside your Databricks. Try to understand how to work with this data lake inside your Databricks. And if you want to work with same with AWS services, then there is something called as Apache Iceberg. It's a highly demand things, and you have to build a one end-to-end project using this particular Delta Lake or Apache Iceberg. Once you learn all these things, there is one more additional tool that is optional but valuable also. That is something called as a Matillion. Matillion is a low code or UI based ETL or ELT pipeline tool. It is similar to that of your ADF, but it integrates well with respect to your Snowflake and other things. You can bring the data from on-prem to that your Snowflake. We can create all your objects inside your Snowflake using Matillion through UI. You don't need to go and do coding anything inside Snowflake. Using UI, you can orchestrate all those things. It's alternative to that of your DBT or Airflow or ADF. That's alternate service. And some of the companies are using Matillion. You can go and master. Since you have learned ADF, you have learned AWS, it will be not much hectic to master this. All the foundation remains same. We only need to understand how this particular UI works, how we can integrate our services with respect to Matillion. Now, this is what are the highly demand skills that are there. And for your final notes, what I can say is learn the concept, not only learn the concept, apply that through code, automate and integrate, build an end-to-end pipeline, transform, load, and serve that purpose. A purpose should be there for building any pipeline. Don't only stick to one cloud. Try to deep dive into one cloud and learn little bit on the other clouds also. We must have an idea on how to integrate your every project with respect to Git, how we can move from one environment to another environment. That you need to have an idea. Don't be a DevOps data engineer, but you need to have an idea on how to move the code from one environment to the another environment. Then build as many projects that is required to get that particular confidence. Now, you might come and ask, Sagar, these are so many things that are there. How much time it requires to learn these things? If you put 4 to 5 months of efforts, daily 1 to 2 hours of efforts, that is more than enough to learn this particular tech stack. And how much salary and how I need to target to learn these things, I'm explaining using this. Now, you have 2 to 3 years of experience you want to show inside data engineer. And I don't want to go heavy coding. I want to just get started. Then you go with something SQL, data warehouse, Snowflake, and DBT. But the salary expectation will be the number of years of experience into 3 is a minimum salary expectation, but it also depends on your current salary. But this is what minimum expectation you can take. For 4 years of guy, we can expect up to 12 to 15, 12 to 16 LPA for showing 2 to 3 years inside your data engineering with less coding. Now I want to, it's okay. I am ready to put efforts. I'll be doing more coding. Then on top of your DBT, add Python, Airflow, Spark, and AWS services and get started with that. Now your salary expectation will go. Now we have whatever the number of years of experience into 4 to 5 because you are showing your coding, you're good with Spark, you're showing AWS services. That's the reason the expectation of the salary is also keep going. So one thing I would say, learn coding. Coding will never let you down. If you lose job also, another job will be keep on waiting as soon as well you are in coding. So Python is very easy to learn. And once you master Python, I would not say you will be able to master Python in 1 or 2 months, but at least you need to have the idea to clear the interview and work in day-to-day activities. You need to know about Python. So if you were able to stretch that for 1 or 2 months extra, and you are okay to do little bit of more coding with respect to Python, then go and learn these things. Now, if if you want to show 3 to 5 years of experience inside your data engineer, but I don't want to go with respect to more coding, then you have to add additional ETL tools like Matillion, ADF, data modeling, and also you need to add a little bit how to integrate with respect to AWS services because you need to have that particular knowledge. And the salary expectation is number of years of experience into 4. You have 5 years of experience and you can go up to 20 LPA to 24 LPA based on max, I would say, but minimum I am saying this into 4. Okay, then 3 to 5 years and you are okay to do more coding, then add other things like Databricks, open table formats, AWS service, ADF, everything you can add and your salary expectation will also keep on increasing. And if you are having 5 plus years of experience, you want to show in data engineer, you need to learn each and everything. You need to build all the products, all the projects, whatever we have discussed, we have to build that on all other products. And we can expect up to 5 to 6 of your number of years of experience. Now, that doesn't mean that you have 10 years of experience and you'll be getting 50 to 60 lakhs. I'm not saying that. It depends on your current package. But at least for 10 years, you can go up to 40 LPA, because as your number of years of experience increases, there is a limit inside your data engineering or any IT field. That limit will be there. Okay. Now, this is how you have to follow any of the data engineering roadmap. This is a very high level. I try to explain. I need to give a brief idea what all you need to concentrate, because nowadays there are n number of tools that are available inside the job market or inside any of the platform. They are showing n number of tools, but these are the highly demand tech stack which we can see in our current data engineering job market. And in coming days also, these technology will be keep on increasing in high demand. Now, that being said, if you want to learn each and every services in well structured format, we are getting started with a next AWS Snowflake multi-cloud data engineering batch from August 18th. You can contact our admin or join the WhatsApp group that has been added inside our description. We'll be more than happy to help you guys with this well structured roadmap, and we'll be teaching each and everything how you can master these things. But just I wanted to say, learn data engineering. If you don't want to join us, that's fine, but give a try by yourself. Try to build as many as projects, try to implement the practical concepts and learn by building the pipelines rather than only reading about the theory. That being said, see you in the next video. Keep learning, keep growing. Thank you.